Morning all. Looking at probability, well, we're carrying on with probability, experimental probability and relative frequencies. So I want you to make some notes as normal. Then hit pause and then write down your heading, lesson objectives and the keywords. Bias, equally likely, experimental data, probability, historical data and trials. Good. Move on to starter. There you go. Hit pause and answer the questions. Off we go. Okay, let's do some solutions then. Question 1. What's the time difference between 9:08 and 11:55? So on 9:08, 9:28 even. If we take that to 11:28, that's 2 hours. And if we take that to 11:30, that's 2 minutes. And from 11:30 we can go up to 11:55 then. That's 25 minutes. There's a total of 2 hours and 27 minutes. Good. Question 2. 3x minus 21 equals 9. Show that x equals 10. So we want to solve it, get x on its own. We've got 3x minus 21 equals 9. What's my first step then? Hopefully you said float and paint, so I'll put a bubble around my 21, float it over the equal sign. So minus 21 on this side, so on the other side is going to be plus 21, so 3x is going to be equal to 9 plus 21. 9 add 21 is 30, so 3x equals 30. But on my float and paint, now to get x on its own, I've got to do the escalator. The 3 goes down the escalator under the 30, so x is equal to 30 divided by 3, which is equal to 10. Number 3, 23 meters to centimeters. This means we've got 23 times how many centimeters in a meter? 100. That gives us 2,300 centimeters. And here we've got 23 times millimeters to meters. It's 1,000. So that's going to give us 23,000 millimeters. And question 4, the answer is 180. What's the question? 90 add 90. Basic and simple. That works. Anything that works. 1 plus 179 equals 180. 45 times 4, 180. 360 divided by 2, 180, and so on. Anything you've got, I shall take. Good? I'm moving on. So, relative frequency. Relative frequency is where we estimate the probability of an event happening by looking at experimental or historic statistical data. If we've got data that we've taken in an experiment, we can use that then to estimate whether on a certain number of trials what is going to happen. So relative frequency is this is our definition: the number of times that the event occurs divided by the number of trials. So the number of times that the event that we're looking for occurs divided by the number of trials. We have a look at an example here, an experiment, say, throwing a biased die. So a biased die, we're going to throw the biased die a certain number of times to find out then which number is more likely to come up. So our possible outcomes are 1 to 6, and here we've got the frequency. So we've done our experiment, and Number 1 came up 25 times, number 2 came up 34 times, 3, 32, 4, 30, 5, 34, and 6, 95 times. So we're looking here at it's highly likely that you get a number 6. So this is a coin I would take if I was going to gamble. Okay, this is a die I would use if I was going to gamble. So first we've got to look at a total number of times that we've done the trials. So we've got to add all these frequencies up. 25, 34, 32, 30, 34, and 95 gives us a total of 250 trials. So we've tossed a coin 250 times. Relative frequency is then the probability of number 1 occurring. To work that out, I do 25 divided by 250, which is 0.1. You can use your calculator for the rest. And what I want you to do now is pause it and then fill in the blank spaces. The next one is going to be 34 divided by 250, and so on, 32 divided by 250. So before you see the answers, off you go. Hit pause. Okay, 34 divided by 250. You should have 0.136 on your calculator. And then we do 32 divided by 250, 0.128. 30 will give us a probability of 0.12. 34 is a probability of 0.136, and then 95 is the highest number of times it's occurred. It's almost 3 times as likely to as any of the others, or in some cases even more. So it's 0.38. So it's heavily biased towards a 6. So you want to be gambling against anybody who's got that die. And then, so that's an experiment. So we experimented and we can see then that the die is biased. You can also do a survey of the number of cars, of the color of cars passing traffic lights. So someone's collated this data for us. Red came up 50 times. Red cars came up 50. Blue is 80. Green is 30. White is 40. Silver 130. And black is 20. So in exactly the same way, now we've got to find the relative frequency. What's the probability that it's going to be red? First things first. Correct. Find the total number of trials by adding these numbers together, and give us a total of 350 trials. So that means they've watched 350 cars. And the probability of red is going to be 50 divided by 350, which is 0.14. So hit pause and complete the table for me in your books there. Good. And 80 divided by 350, give you 0.23. 30 divided by 350, 0.09. 40 divided by 350, 0.11. 130 will give us a probability of 0.37. And finally 20 will give us a probability of 0.06. So which car is most likely to occur when this survey was taken? Silver, 130, 0.37. High probability of a silver occurring. Okay, let's carry on. We looking at this data then. The number of times that the event occurs divided by the number of trials, so total number of trials, and for 1 is 25. So that's our formula for finding the relative frequency. Probability of the next row being the 6 is 0.38 or 38%. Just converted the decimal to percentages. Probability of a 1 is 0.1 or 10%. Probability of a blue car is 0.23. Probability of a silver car is the highest probability of cars, 0.37. Right, looking at this experiment then, we can use this information which we got from an experiment to determine the number of times an event is going to occur with a given number of trials. So they give us a total number of trials. So if they use this information here to estimate the frequency of each number on the die for 1,800 throws. So if we throw a die 1,800 times, how many of those times are we going to get a 1? Any ideas how we work it out? Probability of 1 is 0.1. So this number of throws is 1,800. If we multiply 1,800 by 0.1, that will give us the number of times we're going to get a 1. So probability of getting a 1, or the number of times we get a 1, 180. Number of times we get a 2, 0.136 times 1,800, 245. I want you now to complete the number of times you're going to get any of the other numbers on the die. Hit pause and off you go. 3 with 230. 4, 0.12 times 1,800, 216. A 5, 0.136 times 1,800. And a 6, highest number of times, 684. Most likely to get that. So that's how we can use the information from our experiment to work out then, if say we had 1,800 throws, and the number of times we get a 1, 2, or a 6, or a 5, and so on. This is the information we got in the data survey. So the probability of a red car passing is 0.14, blue car 0.23, and so on. So we're going to use that information again to estimate the frequency of each car color if 2,000 cars passed. So 2,000 cars. So the number of red cars that will pass if 2,000 cars went by would be 0.14 times 2,000. 280 red cars. Number of blue cars, we take the probability of a blue car, 0.23, and then multiply by 2,000. And so on. So I want you to hit pause again, complete this table in your books, and when you're ready to see the answers, hit play again. Probability of a green car, we should have 180. A white car, 220. Silver car, we need the most number of cars because it's got the highest probability, 0.37. We should have 740. And the black car, 0.06 times 2,000, 120. Okay. Question, more exam-based question. Got our formula there. Number of times the event occurs divided by the number of trials is our relative frequency. And so we've got our worked example here. It says a bag contains an unknown number of discs. Rebecca selects a disc at random, notes its color, and then replaces it. So she replaces it back in the bag. She does this 500 times, and her results are recorded below. Rebecca hands the bag to Peter, who's going to select one disc from the bag. Use the information from the table to find the estimates for the probability that Peter selects a red disc. And she had 500 goes. So we can work out the probability of any of these colors then. Probability of red is going to be 200 out of the 500 times. So the probability of Peter selecting a red disc is going to be 200 over 500, which is going to give us a simplifier as 2 over 5, which is 0.440%. And the probability that he selects a blue disc, got 8, so P red was 200 over 500. Probability of blue is going to be 8 divided by 500. That's the probability of blue. 8 divided by 500 is 0.016 or 1.6%. And then finally, the number this time, not the probability, but the number of yellow discs Rebecca could expect for 1,800 trials. The number First we have to work out the probability and then multiply it by the number of trials. Probability of yellow is 115 divided by 500. Then we multiply by the number of trials. So that's the probability of yellow, 115 over 500 or 0.23. And then we multiply it by the number of trials, 1800, and we got 414. Okay. So we can also use relative frequency then in situations like this with the spinners. So it's a theory we're going to apply. So the sections on each spinner are of equal area. State the relative frequency for the number indicated on the spinner. So what's the relative frequency of this case? Is a 4. You got 2 4s out of 1, 2, 3, 4, 5. So that's going to be a probability of 4. P4 is going to be 2 out of 5. And then in the second case, we're looking at the number the arrow is pointing to is a 5. And we've got 3 5s out of 6 altogether. So we've got 3 out of 6, which will simplify to a half. And finally, in this case, we've got the arrows pointing to a 9. We've got 1, 2, 3, 4, 5 9s out of 1, 2, 3, 4, 5, 6, 7, 8. So the probability of a 9 is going to be 5 out of 8. Okay, good. So using those probabilities then, we're going to determine, first one is 280 spins, 500 spins, 720 spins. It wants us to estimate the number of times you expect the pointer to land on the indicated number. So the number of times that the pointer would land on a 4, you know the probability of getting a 4 is 2 out of 5. So the 2 out of 5 times 280, you can use your calculator. And that should give you 112. Hit pause and complete the last two for me. The number of times you get a 5 when you go 500 spins, and the number of times you get a 9, that's a 720. Hit pause when you're ready to see the answer. Hit play again. Number of times you expect to see a 5. Now we know that to get a 5, the probability was a half. So it would be a half of 500. It's 250. And 720 spins. And we knew the probability was 5 out of 8. So it would be 5 out of 8 times 720. I believe that should give us 45. 450 rather than 45. 450. There you go. Okay, 3 questions for you. Similar to the last one. Hit pause and attempt those 3 questions. Off we go. And now we're back. So the number of times you get 400 spins, sorry, you get a 6. Would be, you got 3 60s out of 5, so 3 out of 5 times 400, you should have 240. Number of times you get a 2, 1, 2, 3, 4 2s out of 6, so 4 out of 6, or 2/3, times 270, 180. And number of times you get a 7, 3 7s out of a total number of 8, so 3 out of 8 times 560 gives you 210. And some questions for you. Exercise 9.2, experimental probability or relative frequency. Start at question 1, and off you go. Starts on page 228, and I want you to finish on question 10. Good. Good luck.